In this final summary video for topic 4 waves, I'm going to talk you through standing waves, and it's important in music because it's the physics behind most musical instruments, for example stringed instruments or brass instruments or woodwind instruments. Basically what happens is we have two boundaries, and we have a travelling wave in the medium which travels in one direction, hits a boundary, and then moves back in the opposite direction, and the reflected and the incoming waves meet, and at certain conditions there'll be positions where you have zero displacement. These are called nodes, and there'll be some positions where there is a maximum displacement. That's called an antinode. So when we have a standing wave in a string, the lowest frequency we can hear, the so-called fundamental, is when we can fit in half a wavelength into this one length of the string L. So the length is equivalent to lambda over 2, therefore lambda is equivalent to 2L, therefore the frequency of the fundamental is V, the speed of the wave in the medium, divided by 2L. The next harmonic is when we still have to have two nodes at either end, but we can fit in another node in the middle. So here the length equals 1 lambda, therefore lambda equals the length, therefore the frequency of the second harmonic, or rather the frequency, the next frequency is equal to V over L, which is the same as 2V over 2L. The next harmonic, we can fit in one more antinode, one more antinode and one more node, therefore the length is equivalent to 3/2 lambda, the lambda is equivalent to 2L over 3, and F3 is equal to 3V over 2L. So the pattern is, for the Fn, the nth harmonic is equal to NV over 2L, where n can be 0, 1 or 2. However, the situation is slightly different for a standing wave in a pipe open at one end, and you also have to know about there can be boundary conditions where you have pipes open at both ends, but I'm only going to show you in this video where you have pipes open at one end. Because air particles cannot move at the surface, we have to have an antinode here, but in order to hear a loud sound we have to have maximum displacement at the opening. So we can fit in a node here and an antinode here. So the length corresponds to lambda over 4, therefore lambda corresponds to 4L, and the fundamental frequency here is V over 4L. However, the next time, or the next wave we can fit in is when we have a node here, antinode, node, antinode. So we have to have an antinode at the edge, remember, and a node at the boundary. So here the length is 3 lambda over 4, lambda is 4L over 3, therefore F3 is 3V over 4L. This is the first harmonic in this case. The next time we hear a sound is in this situation. We have node, antinode, node, antinode, node, antinode. So the length corresponds to 5 lambda over 4, lambda equals 4L over 5, and F5 is equal to 5V over 4L. So the indices here, we can only have the odd harmonics. N can only be 1, 3 or 5, and we have this formula Fn equals NV over 4L. So standing waves is the phenomenon where we get at certain frequencies waves which upon reflection have parts of the wave which have zero displacement, they're called nodes, and parts of the wave which have maximum displacement, antinodes, and it means we can perceive sounds in musical instruments.